So today we are going to be talking about topic 2.5, reasoning in algebra and geometry. So what this means is we're just continuing on with learning about proofs. Today we're going to learn about some different properties of equality. The first one that we're going to talk about is reflexive property. This is just telling us that if something is written on one side of the equal sign, it's also written on the other side. So in this case, it has a plus b equals a plus b, or 4 equals 4. So again, the same thing is written on both sides. So in that first blank, you're going to write same. So later on, we're going to have some problems that is going to ask you to give a justification for why you're doing something or why something is. Reflexive property, if you see two things on both sides of the equal sign that are exactly the same, like this 4 plus or 4 equals 4, then you know you have reflexive property. The next thing we're going to go over is symmetric property. Now, it's going to be very easy to get symmetric property and reflexive property mixed up because they're pretty similar. But symmetric property is different because it's just saying that if A equals B, then B also equals A. So if I have 4 plus 5 equals 9, then I could also say 9 equals 4 plus 5. So the sides of the equation switch. Okay? You could also say it as if 2 times 3 equals 6, then 6 is also equal to 2 times 3. It's just taking what's on one side and switching it to the other side because an equal sign can work both directions. Next, we have transitive property, which means if A equals B and B is equal to C, then A is also equal to C. So how we can use that? If we have an expression like 3 times 3 equals 9, and another one that says 9 equals 4 plus 5, we could also write 3 times 3 equals 4 plus 5 because both sides of this equal sign equal 9. Because if I take 3 times 3, we just learned that's 9. 4 plus 5 is also 9. We can set those equal to each other. Next, we have substitution property. And what that tells us is that if A equals B, then A can be replaced by B. Now, this is something that you've already been doing in this class, and you did a bunch in algebra. You just didn't really know there was a name for it. So whenever you solve for x, and then you plug x back into your original equation, that is substitution property. Because if you have x is equal to something in an equation where it says x, you know that x equals that number. Like in this case, we have x equals 5, and it's wanting us to find 4x. So instead of that x, we could write 5 and say 4 times 5 equals 20. So just know, substitution property, if you have something equal to something else, those things are interchangeable. So now we're going to do a little bit of example problems. It's going to give us an equation, and we have to you have to tell what reasoning there is for why we can complete this step. So we didn't go over this one yet today. However, you should know it from algebra. If we have the expression 5 times 4 plus 6 is equal to 20 plus 30, how do we know that this is equal to this? Well, you take this, we know that if we're solving an equation, we have to take this 5 and distribute it to each of these numbers inside of the parentheses. So this is just called distributive property because we're distributing that 5 to both the 4 and the 6. Because 5 times 4 gives us this 20, and 5 times 6 gives us 30. So this whole thing together is an example of distributive property. The next one is x equals 10, and then it also tells us that 5x equals 5 times 10. Well, this is the one we just went over. We know that x equals 10, and we're given this expression 5x, so we can replace or substitute this x with 10. We know this because of the substitution property. The next one, we have 5 times 4 plus 6 on one side and 5 times 4 plus 6 on the other side. Both of these sides are exactly the same. And the property that we've gone over, where we have the exact same thing written on both sides, is the reflexive property. So you'll write reflexive next to it. Then we have if 5 times 4x equals 5 times 10, then 5 times 10 equals 5 times 4 plus 6. So this was on the left side of the equation, but switched to the right side of the equation. So we have to think back to our properties we just went over, to which one is where they switch sides of the equation. And that's the symmetric property. Because if A equals B, then you can also write it the other direction and say that B equals A. Lastly, we have a series of 3 different equations. And if we look back in our notes, there's only one that shows 3 different equations together, and that's the transitive property. But we could also, if you're having issues, we can look back and say, okay, 5 times 10 equals 5 times 6 plus 4, and 5 times 6 plus 4 equals 20 plus 30. Then 5 times 10 equals 20 plus 30. So we had this is A and this is B. And then we had this is B and this is C. So we could also say that A is equal to C. So again, it's transitive property. So next, there's a couple more properties of equality that we need to go over, but these are all essentially using the same idea that if something happens on one side of the equation, it also must be done on the other side of the equation. Again, these are things that you've already been doing or have done in algebra. This is just putting a justification as to why we do these steps. So the first one is addition property. So if we're given that A equals B, then we could say A plus C equals B plus C. Because if we're adding C on one side, we also need to add C to the other side to continue to have these things be equal. So an example is if x equals 12. If I'm put x plus 3 on one side, I have to add 3 to the other side because otherwise x and that number would no longer be equal to each other. Next, we have subtraction property. So that's if a equals b, then a minus c equals b minus c. So again, if we had x equals 12 and we subtract x by 3, we also have to subtract 12 by 3. Then we have multiplication property. If a equals b, then a times c equals b times c. So if x equals 12 and we multiply x by 3, we have to multiply 12 times 3. Division property. Again, if we divide a by c, then we have to divide b by c. So if we have x equals 12 and we divide x by 3, we have to divide 12 by 3. So what is important to remember for addition property, subtraction property, multiplication property, and division property, that if you do something to one side, you have to also do it to the other side. Because we don't want the value of the equation to change. Like we still want x to be equal to the number on the other side. So now we're going to do an example problem like how an actual proof is set up. So we are given that negative 27 plus 6y equals 3 times y minus 3. So that's going to be our given step. So next to that step, write given. What it's wanting us to do is solve for y. So the next step in solving for y, we have to take this 3 and we have to distribute it to the y and the minus 3. So, like I just said, we're distributing it, so that's distributive property. So now we have negative 27 plus 6y equals 3y minus 9. Our next step is we have to add 27 to both sides. So we add 27 to this side, and we add 27 to this side. So on our left side of the equal sign, those 27s are going to cancel out. On the right side, we're going to end up with positive 18 because 27 minus 9 equals 18. But we added something to both sides, so we know that is addition property. The next step in solving for x, we have to subtract 3y from both sides because we're trying to get all the y's onto one side over on the left side. So we're going to subtract 3y from the right, and we're going to subtract 3y from the left, and we'll end up with 3y on the left here. So our final equation is 3y equals 18. Lastly, to get y by itself, we have to divide by 3 on both sides. And we know if we're dividing something on both sides of the equation, that's division property. This next one, it gives us 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. So at this point in the video, go ahead and pause and try to work it out yourself, and then I'll go over the answer. So pause it and try to give it a shot. All right, so the equation that you start off with is what's given. So you'll just write given next to that equation. Again, it's just asking us to solve for x. The first thing we have to do when solving for x is deal with the things that are inside the parentheses. So we have to distribute this 3 into this equation, and then we have to distribute this 2 into this equation, or this set of parentheses. So we have distributive property, because the first thing we have to do is distribute. So that gives us 6x minus 3 minus 6x minus 8. Again, we're trying to solve for x. The next thing we do is combine like terms. So 6x minus 6x, those will cancel each other out. You have minus 3 and minus 8. So negative 3 minus 8 will give you negative 11. And then this 11x will just move down because there was no terms to combine on the right side. So we'll have negative 11 equals 11x. Then solving for x, we have to divide 11 on both sides. So we know if we're dividing something on both sides, that's division property. So you'll write division property. So that gives us negative 1 equals x. However, we could write that in the other direction because we know from symmetric property that the equal sign works both ways. So we could say negative 1 equals x or x equals negative 1. All right, that's the end of the notes for topic 2.5. If you have any questions, feel free to email me or send me a message in Canvas. Or if you're really not understanding this, come in for tutorials. Just let me know if you need any help.